Okay, so this video is going over what or how to do some of the equations using what we learnt from week 1. So the first question that I have here is a question from lesson 3.2. It's question 3 on page 267. So the question is, look at the parabola, so our picture here of a parabola, and then we have to work out these 5 things using that picture. So we know that a parabola is a graph of a quadratic equation. So it says, what are the coordinates of the vertex? Now we have to remember that the vertex is the point on the graph which is the greatest when our coordinate opens up, or the least when our coordinate opens, when our coordinate opens down, it's the greatest, and when it opens up, it's the least. So in this case here, our parabola opens down because the opening is down. So our vertex is going to be the greatest point. So the highest point on our parabola is right here. So if we put a dot here, and we just need to find the coordinates of that. So we can easily just read that straight off the graph. Our x coordinate is 3, and our y coordinate is 2. B then asks us, what is the optimum value? So this is where we need to remember what optimum value is. And our optimum value is our y coordinate of the vertex. So our optimum value would be 2. And is this a maximum or a minimum? So it's a minimum if our y coordinate is negative. It's a maximum if our y coordinate is positive. Actually, that's not true. I should say it's a minimum if our y coordinate opens up. It's a maximum if our y coordinate opens down. And in this case, it opens down, so it's going to be a maximum. All right, so C, it says, what is the equation of the axis of symmetry? Now, we have to remember that the axis of symmetry is what cuts our parabola straight in half. So it's going to be symmetrical on either side. Now, our axis of symmetry always goes through our vertex. So if I drew our axis of symmetry in here, it would be going, oh, it's a bit of a wonky line, but you get the point. It would be going straight up and down here. And it only has an equation with an x value because it's a straight line. It's never going to cross our y axis here. So our equation for this is always going to be the x value of our vertex. And we would write that as x equals 3 because it cuts through the x axis at 3. D asks, what are the zeros of this quadratic relation? So our zeros then, we have to remember, are where our parabola crosses the x-axis. So we have 2 here. We have one at 6, 0, and our other one where it crosses the x-axis is here at 0, 0. Finally, it says, if you calculated the second differences, what would their sign be? Explain. So our second differences, if we have our sign of our second differences is, if our sign of our second differences is a positive, then our parabola opens up. If the sign of our second differences is negative, then our parabola opens down. Now we would look at our graph here and say our parabola opens down. So that means that our sign would be negative. Alright, so let's have a look at another question then. So this is from lesson 3.4, page 280. So the first part of the question says, examine each parabola. What are the zeros of this quadratic equation? So we already went over that. What are our zeros? Our zeros are where our parabola crosses the x-axis. So if we look at A here, we can see that our parabola crosses the x-axis here and here. Now if we're looking at how our graph goes up, it goes up in 5, so 5, 10, 15, 20, 25, 30. So we can say that our first zero is going to be at 5, 0. Our second zero is going to be at 30, 0. Now if we looked at 1b, we can read that off again. So our first zero is going to be here, and if we look again at how it is going up, it goes up 0, 20, 40, 60. I would say that it is going up. That's interesting. I would say that it would be negative 50 and positive 50. Now we're being asked to find what is our axis of symmetry. So in our first one here, we can probably read that one off quite easily. Our axis of symmetry would be x equals 0. So you can read off where our middle point would be. However, on our first graph, it is not as easy to read this one off. So there is an equation that we can use, and that would be adding our two zeros together and then dividing it by 2. So 5 plus 30 divided by 2 would be 35 divided by 2, which is going to give us 17.5. We'd write that as our equation. X equals 17.5. And if we had a look here, that would be about right, because you would think that the axis of symmetry would be somewhere around here. Right. So if we have a look then at this question, for each equation state the x-intercept, the axis of symmetry, and the vertex coordinate. So what we've been doing in the last two questions is looking at a graph and getting information from the graph. Now what we're doing is looking at the equation and getting information about the graph from the equation. So we know that if we have our factored equation, it would be y equals a x minus s x minus t, where s and t are our zeros. So we are first being asked to state the x-intercept, and that is our zeros. So where the parabola crosses our x-axis. So we can say, okay, we have 4 and 2. They are our zeros in this equation. However, we have to remember, we have to also look at the sign that is in front of them. Because if we have a positive number going into an equation, if I was to put a positive 2 into this equation here, the sign would be negative. However, if I was to put a negative 2 into this equation, the sign would become positive because a negative and a negative is a positive. So back to our equation here. Because it's a positive sign here, I know that the x-intercept is actually going to be negative. So we have negative 4, 0 and negative 2, 0 as our x-intercepts. Let's label this as 1. Now we have been asked to find our axis of symmetry. So we can do that by adding together our two x, or 2 zeros, so negative 4 plus negative 2, and then dividing it by 2. So negative 4 plus negative 2 would end up being negative 4 minus negative 2 over 2, and that gives us negative 6 over 2, which gives us an axis of symmetry equaling negative 3. Finally, we've been asked to find our vertex coordinate. So now our vertex coordinate is our coordinate of either being the greatest most point, so greatest most point, or our least. So what we can do is we can write our equation and we can actually insert our x value that we found for our axis of symmetry, because remember, our axis of symmetry is the x value of our vertex. So I can add that into my equation of negative 3 plus 4, negative 3 plus 2. And all that then is left for us to solve for is y, and that would be the y value of our vertex. So y equals negative 3 plus 4, which is 1. And negative 3 plus 2 is negative 1. Now we multiply those together, and y equals negative 1. So now we have our y value of our vertex and our x value of our vertex. So we would put them together and say, therefore, our vertex is negative 3, negative 1. All right, and finally, let's go over how to find a when we are given an equation and a point on the graph. So what is a in our equation here? A is just a number that tells us a little bit more information about a graph. So if you remember when we were talking about a, if we talked about a before, we said that when a is greater than 0, the parabola opens up, and that means that we have a minimum value for our vertex. If a is less than 0, so a negative number, the parabola opens down and our vertex is a maximum value. So that makes sense there. So, like I said, a is just a number that tells us a little bit more about our graph. Does it open up? Does it open down? Is it a maximum or does it have a minimum? All right, so let's see how we find a then. So I have an equation here, but I have at the moment 3 unknown variables. What my extra point on the graph does is take away 2 of those unknown variables. So we actually then only have 1 unknown variable left to solve for. So I'll show you what I mean. We are given an x and a y. So what I can do is I can actually insert the x here and the y here. And that leaves us only with an unknown of a. So 5 equals a, 3 minus 2, 3 plus 6. Now that we only have one unknown, we can solve for that one unknown. So we would solve inside our brackets first. All right, and then we're going to multiply our brackets together. And k. And now to get rid of our 9 on this side and get a all by itself, we're going to divide this side by 9. So that means we have to divide this side by 9. So we would end up with a, that's an a, equals 5 over 9. So that would be our answer there. And if we wanted to write that and put that back into the equation, it would look like there we go. So I hope that that helped you to take the definitions that we learned in the first part and put them into actually using them and working out answers to different questions.